Hi everybody. In this video we're going to be looking at some tips, some hints, and reminders for the topic of chemical nomenclature. The number one thing that you need to do in this topic is first to identify when you're looking at a compound, is it an ionic compound, is it a molecular compound? So what do you look for to identify an ionic compound? Here are some things. A metal is the first element listed in either the name or the formula of the compound. Aluminum chloride, zinc bromide, gold 3 nitrate. These are all examples of ionic compounds because they contain a metal, aluminum, zinc, gold. Remember that the metals are elements below and to the left of the stair-step divider on the periodic table. Next, do we have a compound which lists a positively charged polyatomic ion like ammonium, NH4+, which is listed first in the formula of the compound? Ammonium hydroxide, NH4OH, is an ionic compound for this reason and will follow the conventions for naming an ionic compound. Finally, this one is kind of gray area. If you see that hydrogen is the first listed element in the name or the formula of a compound, normally we're going to name this using ionic naming conventions. For example, HF, we will name this hydrogen fluoride. Again, this is a gray area. Hydrogen fluoride or similar compounds like hydrogen chloride are actually a little bit ionic, a little bit covalent. Now, how do we identify molecular compounds? The key thing to look for is both elements or all the elements present in the compound are non-metallic elements. So these are elements located above and to the right of the stair-step divider on the periodic table. So we see examples N2O4, nitrogen and oxygen are both non-metallic elements. Phosphorus and chlorine are both non-metallic elements. And we see those combination here, oxygen and fluorine are both non-metallic elements. So all of these would have covalent bonding. They are molecular compounds. Another big concern is making sure that we're correctly using parentheses when needed for ionic compounds. For example, if we have iron 2 hydroxide, the iron 2 tells us that the iron ion has a positive 2 charge. Hydroxide ion has a -1 charge, so we need a 1:2 ratio of iron to hydroxide to get a neutral compound. Electrically neutral compounds have no charge. So very often students will write this like this. This doesn't mean that you have 2 hydroxide ions. It actually means that you have 1 iron, 1 oxygen, and 2 hydrogen. So to indicate that we have 2 hydroxide ions, we need a parentheses, which will be followed by that subscript 2. This distributes the 2 to both the hydrogen and the oxygen. If we have iron 3 hydroxide, the correct way to write that formula is shown right here. Please note when I'm naming these compounds, iron 2 hydroxide, iron 3 hydroxide, the 2 or the 3 is the Roman numeral, which is indicating the charge of the positive cation, which is the iron. Here we have iron with a positive 2, here we have iron with a positive 3 charge. It's important to not use parentheses if they're not needed. If you're only going to have one of a polyatomic ion, you should not use parentheses. For example, sodium hydroxide. Sodium is an alkali metal, has a +1 charge. Hydroxide has a -1 charge. This is an incorrect way of writing that formula. The correct way is without the parentheses. Again, we see another example here. Ammonium has a +1 charge. Hydroxide is -1. The correct way to write the formula is without parentheses. If you have only one of a polyatomic ion, you should not be putting parentheses around the formula for that polyatomic ion. Just a quick reminder here about the diatomic elements. It's important that all chemistry students memorize the following list of 7 elements: bromine, iodine, fluorine, chlorine, oxygen, hydrogen, and nitrogen. Brifclone is the mnemonic that I always used, or the acronym, to help me to remember this. When we have elemental forms of these 7 elements, we'll have a molecule which is 2 atoms bonded together. So they are the diatomic molecules. If we're dealing with molecular compounds, it's important to use prefixes and suffixes correctly. I like to encourage my students to remember the examples of carbon dioxide and carbon monoxide. When do we use these prefixes? When do we not use prefixes? For the first element, if there's only one of them, you're not going to use a prefix for the first element. So we don't say monocarbon monoxide or monocarbon dioxide. It just sounds weird. So if you only have one of the first element, no prefix is needed. Now, if you have a compound like N2O4, now we need to use a prefix for that nitrogen. We would say dinitrogen tetraoxide if it's N2O4. So we want to make sure that you are memorizing the appropriate prefixes and using those in the appropriate places. The second element is always going to get a prefix. The first element, its name is going to stay just the same as what it is on the periodic table. The second element will have its name changed to include the "ide" suffix. So we have carbon dioxide, hydrogen sulfide, dinitrogen tetraoxide. We're always changing the name of that second element to include the "ide" suffix. Thanks for watching, everybody, this brief summary of the topic of nomenclature, important tips, hints, and reminders. We'll see you next time.